afternoon, everyone. How's everyone doing after lunch? Good? Good? We are session number 2, so I think we escaped the post-lunch syndrome, I'll say. Okay, great. Well, on stage with me today, I have Nelson. Nelson, thank you for joining us. Nelson is a research director at JPMorgan Chase AI Research, based out of Paris, but his team is global. His research includes diverse topics, right, from game theory to multi-agent reinforcement learning to quantitative reasoning and to LLMs. We know what's at the core of all things AI and all things data science. Ultimately, it goes down to math, and Nelson is a PhD in applied mathematics as well. So we have the right speaker on stage today to jump into all things AI from a research perspective and understand a little bit more about industry nuances and your view of the world, Nelson. So I'm going to jump right in. Specific to JP Morgan, or specific to the broader banking industry, many of you may have heard about the Evident AI Index. Raise your hands if you have heard about what the Evident AI Index is. Okay, I see a couple of hands. And if you haven't, I highly encourage you to look it up. So JP Morgan is ranked #1 in it across research, talent, innovation, and all of the different other categories. So from a JP Morgan AI research and broadly AI research perspective, do you mind shedding some light on the different areas that you're working on?
Sure. So thank you very much for the introduction. And let me just say a few words about our AI research team. So as you mentioned, it's a team led globally by Manuela Veloso, professor emerita and formerly at Carnegie Mellon University. And so I've been leading our French team since last year, 2023. And so we innovate with the businesses internally across different LOBs, ranging from markets, investment banking, consumer banking, or asset management. But also present our research externally at some of the major AI conferences like NeurIPS or ICML. And some of the topics that we tackle, so the team is quite large. We tackle different topics: AI agents, dynamic decision making, document AI, but also planning and explainable AI. So just taking the example of explainable AI, for example, being able to explain to a trader why a model made a certain decision is quite useful.
Okay, wonderful. So Nelson, we're going to unpack this a little bit this afternoon. One of the core principles, or one of the core capabilities you mentioned, reinforcement learning. It's very unique, it's challenging in a way. We would like our audience to understand from you today, where do you see it useful and what are the different applications broadly in the financial sector?
Sure. So some of you may have heard about reinforcement learning in the context of LLMs, but actually reinforcement learning has many applications. It's basically about maximizing a long-term objective by taking different actions and observing different things and evolving over the course of time and being able to take the actions in order to basically maximize the long-term objective. And so here the long-term feature is key because some of the actions may be suboptimal in the short run, but optimal in the long run. So I don't know, think about finding a treasure on a map, think about playing a game of chess, think about maximizing P&L over a given time horizon. And so you may lose energy by moving on the map, but finally you get a very large reward, you find a treasure. And so this has many applications, for example, in portfolio hedging, where the goal is to keep the risk of the portfolio low. And what you do is basically choosing how much you buy of which options. And what's also really exciting is that this framework allows to incorporate very important things like transaction costs. And so it's something that you can incorporate in the reward function in your RL framework. So when you build something, when you talk about RL, you really need to think about what you can observe, the actions that you can do, and what's your reward. But it's also very, sometimes you just spend a bit of time formulating your problem in the RL framework, and you can get very interesting results. So one example of the work we did is on model calibration. So that's a bit more on the quant finance side, where the goal is to find the coefficients of your model, essentially, of the equations that drive the different stocks, in order to be able to correctly price a set of options. So what's really nice is that, well, you can see all these trajectories that you use to price the options as different players cooperating in a game, in some sense. And so they all contribute to the option price, because the option price is an average over all these trajectories. Yeah, and so then what's really cool is that you can, for example, get, for those of you who know, local volatility from a purely data-driven approach. And you can also, it also allows you to tackle more complex options like Bermudian, for example. But that's, you can read, the paper is available online, so you can also read. And maybe, sorry, finally, last thing, on the multi-agent side, because reinforcement learning is, you can see it as a single agent problem, but also multi-agent. And multi-agent is quite important because what that means is that you have multiple well, participants, each using an RL algorithm. And so all these learning processes interact with each other, and that gives rise to fascinating questions in terms of the skills that you learn, and actually what is going on in the system where you put all these RL agents learning together. And so last year we published an article in the journal Mathematical Finance on modeling the FX spot market using such a multi-agent framework. And so we were able to find the agents learning interesting skills such as price queuing, for example.
Super interesting, Nelson. So as we look at different pillars, we're going to unpack a few of them more in the time that we have left. So we went into reinforcement learning. No discussion on AI is complete without the magic three-letter word or three-letter acronym these days. No prizes for guessing, LLMs. So alongside reinforcement learning, I understand like LLMs is a core area of research, one of the core research pillars of you and your team. And I know there are a lot of exciting use cases or areas of studies that your team has done. So do you mind shedding light on some of these?
Of course. So let me give you a couple of examples. So the first one I will mention is a doc LLM. So as its name suggests, it's a model that aims at reasoning over visual information available on documents. And so here the idea is to construct kind of a lightweight extension to traditional LLMs, where we modify the attention mechanism that occurs in such models. And the idea essentially is that you take the text and together with the text, you put some embedding representing the layout information. So basically, where is the text on the document? And so that information, that spatial information, together with the text, provides a richer set of information to the model and is able to perform quite well on different tasks. And one thing I should mention is that you could also use multimodal LLMs for that, but it's more costly computationally because you need to process an image. So this doc LLM is more targeted, is more like text plus some kind of OCR, visual information acquired through OCR. So for this paper, for the corresponding research was accepted at one of the top NLP conferences this year, so ACL main track. And so, yeah, so it was really exciting to see that. Something else I can mention on a different topic is on the software development. So software development is quite a wide ecosystem. It's not only about coding, it's also about fixing bugs, planning, so what you should code, essentially, testing and all these kind of things. And so the team developed a multi-agent LLM-based framework to basically work together with real-world software development teams. So, in this framework, you have roughly 3 agents. So one is the sprint agent that does the planning of what you should do, then the coding agent that will actually develop the code, and then you have a peer review agent that will evaluate the code. And so these agents are designed to work together with real software engineers, with our software engineering teams. And I think we also have like a summary agent to address the context length issue, so to compactify the information. Yeah, and so to evaluate this, it's not completely obvious because a lot of benchmarks on the coding space are related to isolated coding problems. But here you need kind of a real-world benchmark that reflects the actually real-world software engineering. And so such a benchmark was released last year, SWE. I think it was in fall 2023. And so the model does quite well actually in identifying in which files the bugs occurred in the code. So that was quite nice too. And finally, I will mention our work on the CFA exam. So this is quite a unique work. We were able to acquire vendor data so the CFA exam is a financial exam. It has 3 levels. So we were able to purchase some vendor data, including also textbooks. And the goal was to evaluate all the LLM, both open and closed source LLM on these exams. And so we evaluated the models in 2 settings. So the closed book exam, where you have to rely on your own knowledge, and also the open book exam, where you use retrieval RAG types techniques to retrieve the information from the textbook. And so in short, what we found is that the best models were actually able to pass level 1 and 2. But they all failed level 3. And so level 3 is more about essays. And so, yeah, so that's what we found. Maybe something, I also see the time, something I can mention quickly is that the open book feature, for level 1, all models benefited from it because it's a relatively straightforward textbook application of what you have in the textbook. But for level 2, it's a bit more complex, and so we found that only the larger models were able to benefit because they were able to correctly filter the information that was retrieved.
Wonderful, Nelson, thank you. In the interest of time, we'll make the final question a rapid fire type question, if that's okay with you. All right, so if I were to ask you, what's the hottest area in AI research today? Given everything that's going on in the industry, what would it be?
Yes, so what I'm most excited about is mathematical reasoning with LLMs. So you've maybe heard about the work from DeepMind on International Mathematical Olympiads, as well as the model that was released last week from OpenAI that takes a bit of time before answering a question. So on our side, we are really interested in basically building high quality and relevant data to answer quantitative questions that occur in the space of finance. So this is a bit in line with the work that I mentioned on the CFA exam. Maybe one thing I forgot to mention is that we observed that the models actually in the CFA exam struggled on some financial calculation and reasoning tasks. And so that's why we are interested in that. And so we did a work recently where we fine-tuned some open source models on mathematical data, and the goal was to both study the generalization, but in terms of the number of variables, the number of equations, but also in the ability to use these mathematical skills in different contexts, right? So you maybe ask a financial question, and then you need to answer using your own knowledge, but then at some point, maybe you need to solve an equation, you need to do this and that, and so that's another form of generalization, is the ability to properly basically use these skills. And there's also one thing I should mention is the combination of skills is quite important. For example, if you know how to handle fractions, but you know how to solve equations, then if you combine them, you know how to solve equations with fractions. So that's I'm super excited about that, and I hope to see one day a major mathematical result solved by an AI.
Thank you, Nelson, for that. Thank you for the insightful conversation and the details. When you and I sit together on stage a year from now, I'm looking for what's to unlock for you on your next frontier. So all the best, good luck, and thank you all.
Thank you very much.
You'll see me more this afternoon, but good for now.